Hey everybody, this is Mr. Munson, and we're in Unit 3, Geometry Unit 3, Parallel Lines and Transversals. This is concept number 1 in this video series, and so we're going to call this G.3.1 Special Angle Relationships. Remember, put that title at the top of your homework when you go to do it in a little bit. All right, what we're going to be looking at is if we have two lines like this with another line cutting through them. That's called the transversal, by the way. It creates a whole set of angles, and we want to have a relationship. We want to understand how they're related algebraically, like to help us write equations. And so let's go ahead and get started on that. Okay, so go ahead and set up your notebook paper or notebook. It should G.3.1 Special Angle Relationships. Of course, you can put me on pause and rewind it and listen to the video as many times as you want. Okay, so if I go too fast, just pause and go back. Okay, suppose I have two lines like this. They're not necessarily parallel. They don't have to be for us to have the special names I'm going to introduce to you. But whenever I take another line and bring it through those two lines, right, I have two lines like that and I bring another one through it, it creates a set of 8 different angles. I hope that you can see that, okay? The green line is called the transversal. All right, now I hope that we don't need to go too far for you to understand that we already have some special names for special angles, okay? Like for instance, angle 1 and angle 2 are already known to be a linear pair. That's no big deal. And there's other sets of linear pairs in here. You know, angle 5 and angle 6. Whoops. Angle 6 are a linear pair, right? Those are a pair of angles. Let's write the word pair in up here. Very good. Okay? Now take a look at angle 4 and angle 2. Could you tell me what kind of special name that those have? I'm hoping that without too much fanfare, you know that's a vertical pair. Okay? And we already have a relationship between those things. Linear pairs, those are supplementary angles, and vertical angles are congruent. Well, I'm not interested in going back over those. I didn't have to start a whole new video. Here's where we're going to bring in G.3.1 a brand new set of angles. Now I need you to draw your attention. You might not draw these boxes on your notes because I'm first of all going to be having them in color and all that stuff. It's up to you. But I just need you to understand on this next set of angles, I'm going to always be picking one of the angles from here and one of the angles from here and talking about their relationship, okay? Now in the blue box there, we certainly have relationships between 1, 2, and 3, and 4 linear pair and vertical angles. The same is true for this one. Again, this video is about the relationship where we pull one angle from one box and one from the other. Now in the homework and certainly on practice problems, these boxes are not going to exist. You need to train your eye to see those two sets of angles, the 4 on top, the 4 on the bottom, and if I rotate this drawing in some way, it doesn't change that, okay? All right, so let's look at some special angle pairs. All right, taking a look at this, I have a group of angles on top and a group of angles bottom, and so I'm looking at a set of angles called a consecutive interior angles, okay? So first of all, we have to identify that this is called the interior angles, the ones that are in between the two lines that are being cut by the transversal, okay? So at the very least, as we name these angles, we're drawing from only these angles as we name consecutive interior angles. All right, consecutive means that they're one right across from each other, okay? So this is a pair of consecutive angles right here, that one and that one. So angle 4 and angle 5 are a pair of consecutive interior angles. Can you figure out which one that goes with angle 3? So just put me on pause and see if you can figure it out. Okay, I'm hoping that that wasn't a big deal. It's angle 6. It's the other interior angle, and it's across from 3. That's a pair. Those are pairs of consecutive interior angles. Now remember, on your homework, I'm going to be referring to certain angles, and you're going to need to be able to identify them. I'm going to be talking about the relationships with them later on in the sense of equations. And so as you do the ones for the homework, you're going to want to walk back into your notes and look at these relationships and ask yourself, are these angles supposed to be congruent or whatever? Now, right now, we're not talking about these red lines being parallel, But when we get to the point that they're parallel, then some really special things start happening with the pairs of angles I'm going to be talking about. Consecutive interior, alternate exterior, alternate interior, and then in just a few minutes, corresponding. All right, now let's take a look at alternate exterior angles. Now, one of the things I need you to pick up is when we're kind of trying to sort these different angle names and stuff like that in our head, you know, we have linear pair, vertical angles, now we have consecutive interior, we're going to have alternate interior, alternate exterior. You need to look at the words and start identifying and processing in your head what things allow you to understand what we're talking about here, okay? Let me first of all spell that out. So we're talking alternate exterior angles, okay? Exterior, that's an easy one. Exterior angles are angles that are outside of the two lines being cut by the transversal, okay? So exterior angles would be like this set, 8 and 7, and 1 and 2. Now, we don't need to look at that special pair. 8 and 7 is already known as a linear pair, and the 1 and 2 here is a linear pair. What makes this set that we're talking about now is this first word, alternate. Now the alternate means one is on one side of the green, or one is on one side of the transversal and one is on the other. And 1 and 2 kind of fit that category. But see, we already have a name for that. And remember, I already talked about this. We're looking at special pairs that are formed by grabbing one from one set of 4 and one from the other set of 4. 1 and 2 is in the same set. So let's take a look. This is where we're looking at an alternate exterior angle. Okay, if you take a look at 1, the one that goes with that one that's an alternate exterior has to be pulled from this 4. 8 and 7 are the only ones that are exterior down here. 7 is the only one that's on the other side of the transversal, right? 1's on this side, 3's on this side. That word alternate is telling you 1's on one side, 1 is on the other. All right, angles are on different sides of the transversal. All right, very good. That's what the alternate's going to be. So according to that, angle 1 and angle 7 are a pair of alternate exterior angles. Is there another pair? See if you can check to see if there's another pair of alternate exterior angles that matches what we just described. Put me on pause if you need to. I recognize angle 2 and angle 8 fit the description that I just described. All right, let's go on to alternate interior angles. Once again, we're looking at interior angles. That's the ones in between the lines that are being cut by transversal. And once again, we want to make sure that we're pulling from one from the group top and one at the group at the bottom. So we're looking at 4, 3, 5, and 6. And so we're going to see if we can, that's the reason we're pulling from there is because we're talking interior angles, right? Alternate interior angles. Now, according to what I just set up here, alternate means one's on one side of the transversal, right? And one is on the other. Now 4 and 3 fit that category. There's one is on one side, one's on the other, and they're both interior angles. But we already have a name for that pair of angles. We don't need to be coming up with a different name. That's called the linear pair. So certainly, and also we're pulling, if we looked at 4 and 3 as alternate interiors, we're pulling them both from the same group. We always want to pull one from this group and one from this group. Now, if you ask me, angle 4 and angle 6 fits in that category of interior angles where one's on one side, one's on the other. See if you can come up with the other pair of alternate interior angles. Seriously, put me on pause, do yourself a favor, and just think through this for a few minutes, a few seconds, whatever it takes to figure out what is the other pair of alternate interior angles. I'm hoping that you said angle 3 and angle 5. It's not any harder than that. Okay, I'm going to kind of shrink this down, and I'm going to add one more to our list. Okay, let me just shrink that down. And now I have All right, we're going to look at what we call corresponding angles. Now, corresponding angles, once again, are picking an angle from this set and another one from this set, okay? So we're just not going to use the boxes right now. We want to kind of graduate from that idea of thinking. Corresponding angles are angles that sit in the same spot. So if you take a look at angle 1, that's from this top angle. Now I want to look at down here at the bottom, 5, 6, and 7, and see in that grouping which angle sits kind of in the same spot as angle 1. That's what a corresponding angle would be. I see angle 5 kind of sitting in the same spot, kind of the top right-hand corner or top left-hand corner. So angle 1 and angle 5 are corresponding pairs. Now what I want you to look at, it's kind of interesting, is that I notice it's not saying anything in the name about alternate, so they're on the same side. There's nothing about being interior and exterior angles because one's exterior, one's interior. And that's going to be true for all corresponding angles. One's going to be exterior, one's going to be interior. Okay? All right, now what I want you to do is see if you can kind of walk through and find the one that goes with angle 2. Okay, put me on pause and come back and check to see if you can figure that one out. What is the alternate angle that goes with, the corresponding angle that goes with angle 2? Now I'm hoping that you found the pattern here already. So you have angle 2 and then angle 6. They both are kind of in their top right-hand corner of the set of angles. Okay, I'm going to put a couple more down there. I want you to put me on pause and see if you can come up with those. All right, there you go. Put me on pause and see if you can find the corresponding angle that goes with 4 and 7. Once we're done with these, if you don't quite understand these, there's no need for you to go any further. You need to back up the video because we're going to get into writing some equations with these things. And if you don't understand these names, it's going to just get harder and harder for you. So back up if you need to. Write down 4 and 7's corresponding angle. And if it's making sense, let's progress. Put me on pause, come back and check your work. All right, hopefully you said angle 4 and angle 8, right? They're both sitting kind of the lower left-hand corners, okay? And then we have 7 and 3, kind of the lower right-hand corners. All right, let's move on. All right, now I'm going to introduce you to some relationships, and that is, in this case, the first relationship is corresponding angles postulate. And what this says is if you have a pair of corresponding angles, right? Let's say that's that angle there and that angle there. Now there's several groups or several pairs of corresponding angles. This applies to all of them. But in this case, I want you to look at this conditional statement. It says, hey, if two lines are parallel, and as you can see by the marks here, these little arrow things match. There's 2 on each one. Line T and M are parallel. Then the corresponding angles are congruent. Cool. That means I can write an equation for it, right? Now, because these things are congruent, and this is any pair of corresponding angles, that's telling me how I can write my equation. So suppose this 4x plus 50, right? We have this angle 4x plus 50. It'll grab it. It's not going to let me grab it. 4x plus 50. If I knew that that was the measure of that angle right there, and then this 6x plus 40 was the angle right there, I would recognize, hey, that's a pair of corresponding angles. So now I can write that equation. 4x plus 50 equals 6x plus 40. Now certainly you know how to solve that equation. Now here's kind of an interesting question. I might give you a problem that looks like that 4x plus 50 and everything, and say, you know what I want to know? I want to know what that angle is. So we'd have to solve that equation. Plug that 5 into that equation. It gives me 70 if I do my calculation right. And by vertical angles, I could find that that's 70. We're drawing upon previous knowledge to solve some of these questions. All right, next up is alternate interior angles. Now remember, alternate interior angles, those are going to be angles that are on the inside, and one's on one side, one's on the other. Now notice I'm using arrows, not not just simple marks like this, because that would imply that they're congruent. Okay, I just want to draw your attention to the angles I'm talking about. Well, that's one pair of alternate interior angles. There's another pair there. Well, according to this alternate interior angles theorem, lines that are parallel, when the lines are parallel, then the alternate interior angles are congruent. That tells us how to write the equation. So let's take a look over here to the right. So I give you that angle 4 is 2x plus 50 and 6 is 7x plus 30. Now I look up here and angle 4 and angle 6 are both alternate interior angles. That means I can use this theorem. Go ahead and put me on pause. I want you to write an equation and solve for the x. And then I want you to see if you can think through how you're going to find angle 3. Put me on pause now. All right, and there you have it. This equation right here is possible. These two things are equal to each other because of the alternate interior angles theorem. It says alternate interior angles are congruent. So I find that x is equal to 4. Fantastic. Now, if you haven't found it yet, I need you to think through how you're going to find angle 3. If you already have, hold on for a second. I'll show you that work. All right, well, welcome back, or as we continue. Basically, I took the measure of angle 4, and I found that it was equal to 58 using the idea that x is equal to 4. But I don't want to know angle 4. I'm going to use angle 4 being 58 to find its linear pair. So angle 4 is 58, and angle 3 would therefore have to be 122. Moving on. Okay, similarly, we find that alternate exterior angles, when the lines are parallel, so we have to have that fact first, they're also congruent. Again, I'm not going to give, this is very similar to the ones we've been doing before. If you recognize alternate interior angles are given, or you can find them, you're going to use the equation that they're congruent to each other to solve for x. I'm not going to give you an example because it's quite the same as what we've done so far with the other special angle. Okay, and we have our last theorem. If two lines are parallel, then the consecutive interior angles are going to be actually supplementary in this case, okay? They're going to be supplementary. All right, well, that's telling us how to write the equation for this one over here on the right. So go ahead and put me on pause and see if you can think that through. So what I want you to do is I want you to go ahead and write an equation to solve for x, and then use that to find angle 1's measure. Put me on pause and see if you can think that through. Okay, so there you have it. There's the equation. The sum is equal to 180, and I just solved for x equals 15. Now I'm looking for angle 1. So now all I have to do is take this and plug it into there. When I do that, I get angle 1 is equal to 85, right? 3 times 15 is 45. Plus 40 is 85. All right, there you have it. Go ahead and write your summary, and let's go on to do our do it problems. Don't forget to write your title at the top. These are your do it problems, G.3.1 Special Pairs, and put your name, day at the top. Make sure you're writing the original information. The information I give you should be on your paper as well as your work. Now I'm going to zoom in and maybe talk a little bit about each problem. Okay, so here's problem 1. So I give you some information. Measure of angles 1 is 45. Using the consecutive interior angles theorem, I want you to figure out what 5 is. And using the alternate exterior angles theorem, find out what number 7 is. Number 2, I simply want you to write an equation for x using that same picture above and find out what angle x is, or what x is, and then what angle 7 is. In number 3, what I want you to do, again using the drawing above, is I want you to write an equation. Look at angle 3 and angle 6 and decide, of the special relationships we just talked about, which equation would you write to solve for x? But don't solve. Just simply write your equation. And problem number 4, I want you, again, using that problem at the top, I want you to use angles. Tell me what the list of angles are that are vertical angles in reference to angle 1. Okay? What is the list of linear pair, corresponding angles, alternate and exterior angles? For instance, for the linear pair, you should write angle 2 and angle 4. Put a comma in between there and just list what the angle sets are. And then finally, I want you to do number 5, using the Pythagorean theorem review. Or Pythagorean theorem, this is a review problem. Find y and circle all your answers and bring that into class beginning next period. We'll see you later.